So today we are welcoming Salvador from the Ontology Engineering Group at the Universidad Politécnica de Madrid. And he's a researcher in the AI domain with an excellent knowledge on semantic characterization of digital twins. He has graduated in computer engineering with a master's focusing on AI, and now he is focusing on semantic characterization and interoperability with different digital twins, which is the topic of his PhD work. And with this, I am giving the floor to Salvador. Afterwards, if you're asking questions, just make sure to introduce yourself. So, Salvador, the floor is yours.
This work is called WoTDT Twin Ontology. This work has been made by me, Andrea Chimino, and Raul García Castro. And this work comes from the Cogito European project. That is a construction railway project that is made with a digital twin. So let's start with what is a digital twin. So a digital twin is a digital representation of a physical object or system that can be used to analyze its behavior and effectiveness. So also this digital twin can be represented in 3 dimensions. So the first dimension, as we can see here, is the real world entity, which represents the actual entity in the real world, and the digital entity, which represents the software representation of the entity in the digital world. And the third dimension that is from this 3-dimensional architecture is the bidirectional information flow that are the connections. So we have the real world entity, the digital entity, and the connections between them. As we can see here, in the real world entity, we can have real world actions, and in the digital entity, we can have, for example, simulations. What is the information that is stored in the different dimensions? So in the real world entity, we have the sources of data. The data retrieved from the real entities and sensors or actuators or different systems that are in the real world.
So that's it. In the digital twin, we have the data, the services, and the models. Data can be from heterogeneous to homogeneous data. Services can be, for example, for the simulations, and models can be, for example, an ontology that models all the data in the digital twin. So next, we have explained the 3-dimensional model, but also there is a 5-dimensional model presented by Tao et al. That is presented by different dimensions. In this case, we have the real world entity with the source of data, that is the entity dimension. The models is the virtual entity dimension. The connections between them and between the digital entity and the real world entity are the dimension of the digital twin connections. The services are the digital twin services, and the data is the digital twin data. So we have right now a 5-dimensional architecture within the digital twin. That is going to be the main architecture that we are going to focus within the presentation. So next, we have the Cogito project. What we have in the Cogito project and how can be represented by the digital twin. So first of all, we have the real world entity, where we have 3 pilots, in specific the Austria, Denmark, and Spain pilots. And here we have the digital entity, where all the data is captured from satellite images, 3D scanning, devices and sensors, and we have also data from 3D geometry, budget and cost, and activity schedule. Also, we have a part that is the digital twin platform, where all the data is processed, and then all of this data is used by the digital twin applications. Following the 5-dimensional approach that we explained earlier, we have the entity for the different pilots, the digital twin data for the data captured by the reality tools, the digital twin connections between the reality capture tools, the digital twin platform, and the digital twin applications. And finally, we have the virtual entity for the digital twin platform, that is the one that is going to model all the data, and the digital twin services that are going to be used by the digital twin to make the respective simulations or information transformations. So once we explain the project, I'm going to explain the proposal that we made. In this case, we have the WoT WoTDT ontology. WoTDT ontology has been developed within the Cogito project and describe the 5 dimensions of a digital twin and its features extending Web of Things. So what are the reasons why we made the WoT digital twin ontology? So it is because it allows for conceptualizing the 5-dimensional model architecture and its features. And also, thanks to, for example, Web of Things theme descriptions, we can describe the services of different dimensions. Thanks to WoT discovery, we can discover services across dimensions. And also, thanks for WoT theme descriptions, we can define the security specification of each dimension and facilitates the data accessibility of a specific dimension. Finally, we have to promote the data interoperability in all the different dimensions and provide the direct access to all the digital twin functionalities. And this can be seen in a workshop paper that we just got accepted in the LDAC workshop. Next, as we can see here, we can use WoT in the digital twin to represent 2 different dimensions right now: the digital twin data dimension and the digital twin services dimension. But with WoTDT ontology, we can represent also the virtual entity, the digital twin connections, and the entity dimensions. Okay, so once we explain the digital twin, WoT digital twin ontology, I'm going to show you an overview of the ontology, where we have, for example, here the class digital twin that is subclass of thing, in this case from the WoTDT ontology. And we have here the different dimensions represented in the diagram. So, for example, we have the digital twin entity for the entity dimension, the model for the virtual entity dimension, the resource for the digital twin data, the interaction affordance from theme description ontology for the digital twin services, and finally the connections within the digital twin connections dimension. As you can see here, we are representing the 5-dimensional approach, but also if we look for this class, we have the digital entity. So this ontology also can represent the 3-dimensional approach with the real world entity, the digital entity, and the connections between them. Okay, so let's start, for example, with the WoTDT context. That is going to be, for example, if you want to write it in a JSON LD within a theme description. So the context, we have the theme description ontology URI and the discovery core also URI. But also we have here the raw GitHub link that contains all the context of this ontology. And also we have here the namespaces for the data that are going to be used along the examples of the WoTDT ontology use case. Okay, so let's start for the first dimension. In this case, we have the entity dimension represented by the class entity. So, for example, imagine that you want to represent a digital twin of a wall. For example, in this case, it's called the element 104886. So we have the context that we saw earlier, an identifier for the digital twin. In this case, this is going to be the identifier for the digital twin. This case is a type of digital twin. The title is element and this number. And finally, we have the entity. That is the entity that is going to be represented as a digital twin. In this case, this wall. So next, we have the models. In this case, the virtual entity dimension. That can be from non-semantic models to semantic models. In this case, we have the rules models, behavioral models, physical model, geometrical model, and on the other way, we have the semantic models like ontologies, shapes, or mappings. In this case, we have, for example, the ontology of WoT that is used for the construction modeling. Here we can see an example of the digital twin entity, for the digital entity representation, and in this case for the models. Here we have the ontology, that is the WoT ontology, and can be represented by the subclass of ontology model, the title, builder, and the element ontology, and all the information about it. For example, the different formats that can be obtained, etc. Okay, so next is the digital twin data dimension that is represented by the DCAT resource reusing the DCAT ontology. That is the data catalog ontology to represent the different data sources and data services that provide the information. So in this example, we are going to represent like a data set that, for example, can be a knowledge graph. And here we can see that the data dimension is represented right here, like with the DCAT resource. And in this case, we have the DCAT dataset that is a knowledge graph with its description, its access URL, and the URL if you want to obtain the whole knowledge graph. Once this part is explained, we are going to explain the digital twin services that is obtained basically from the thin description ontology. So we can see here the interaction affordance from the properties affordance and the action affordance. Like, for example, to validate an RDF graph, in this case, we have the URI to access to that service, and also the action for registering a cycle model that also we have here the URI to obtain the different access to register the different cycle models. Okay, so finally, for the last dimension, we have the connection dimension that is represented by the digital twin connection. In this case, we have a provider and a consumer. In this case, for example, we have a model and that is a provider, and the consumer is a service that wants to operate with that model. So we have different types of connections, for example, model to model connection, model data connection, model service connection, and data service connection that are conceptualized like this, to model, model interaction affordance, etc. And the different subclasses of the connection point that we can have are the DCAT resources that are the digital twin data dimension information, the interaction affordances that are the digital twin service dimension, and the different models that are the virtual entity dimension. Okay, so here we have, for example, here an example of a connection that is in JSON-LD, that is in this case a connection between a data and a service. And in this case, is going to be the consumer, the service that in this case is Helio, that is going to materialize the data obtained from here to RDF. So here we have the consumer, that is the service, and the provider is a DCAT dataset that in this case is an IFC file. This IFC file is going to be materialized to RDF data. And here we have, for example, like this is a REST and service and a DCAT dataset. So what were the challenges on reusing WoT things in Cogito? The different challenges that we had were the lack of conceptualization to represent the digital twin dimensions, the lack of conceptualization also to represent some digital twin dimensions features, and finally the lack of representation of the connections between digital twin dimensions and the dimension features. So finally, as conclusions, WoTDT ontology is developed as an extension of the thin description ontology to describe the 5-dimensional architecture approach of digital twins. Thanks to WoT things, this ontology enables a more precise comprehension of the digital twins and provides a direct access to all the system functionalities. And despite being initially designed for the construction domain, this ontology is flexible to incorporate new classes and subclasses to cover different domains, not only the construction domain. And a future challenge that I propose you is the aggregation of digital twins to create an ecosystem of digital twins. First of all, an aggregation of digital twins consists of the combination of two digital twins in order to provide the benefits of one digital twin to the other one linked. An ecosystem of digital twins also can be created within the combination of the different digital twins to generate like a composed digital twin of multiple digital twins. So how to the challenge is how two digital twins can be combined and how WoT things can help at this aggregation. So here, for example, is a little explanation with a representation of the digital twins that we have. First digital twin and another digital twin that that the user wants to interoperate with them. So how can we create this ecosystem that allows this kind of aggregation? And so that's all. Many thanks. So you have any questions?